The Earth is ancient, but it is not still. Beneath the calm of forests, beneath the weight of oceans and mountains, the planet is alive. Its crust floating on a sea of molten stone, drifting and colliding across time. Every second, continents move, slowly, invisibly, carried by the restless churn of the mantle below. What seems solid and eternal is, in truth, fluid. Oceans open, mountains rise, deserts drift, and if we could speed up time, compress millions of years into minutes, the Earth would seem to breathe. Land masses would shatter and fuse again. Seas would disappear. The face of the planet would change beyond recognition. So what will our world look like not in 10 years or 100, but in 250 million years? What new world awaits in the far future, when time itself has reshaped the continents, rewritten the skies, and forged an Earth both alien and familiar? Today's Earth is in the middle of a long, slow dance, one that began when its first supercontinent, Pangaea, broke apart some 175 million years ago. Back then, there was only one vast landmass surrounded by a global ocean. Over eons, the tectonic plates beneath Pangaea drifted apart, carrying the continents to the positions we know today. The Americas in the west, Africa and Eurasia in the east, Antarctica drifting toward the pole, and Australia journeying north. But this movement has never stopped. Beneath our feet, the mantle convection currents still push the plates, dragging entire continents like rafts across molten stone. Every year, the Atlantic Ocean grows wider, by about the length of a fingernail. The Pacific, meanwhile, is shrinking, consumed by subduction zones where ocean crust dives beneath continental plates. It is a slow process, but relentless, and over millions of years, it will reshape the world entirely. Scientists call the next great merger Pangaea Ultima, the last Pangaea. In roughly 250 million years, the continents will collide once more, gathering into a single supercontinent at the heart of the planet's equatorial belt. The Atlantic Ocean, which now divides the Americas from Africa and Europe, will close completely. The Americas will drift eastward, crashing into Africa's western coast. The Mediterranean will vanish. Europe will fold into Asia, creating a vast mountain range that dwarfs the Himalayas. To the south, Antarctica will migrate north, shedding its ice and greening under a new tropical sun. Australia will collide with Southeast Asia, forming a rugged new landmass that stretches from the equator almost to the pole. In this far-future world, the continents are no longer scattered islands in a blue sea. They are united, a single, sprawling continent surrounded by one immense global ocean. The planet's map will bear no resemblance to the one we know today. But with this new geography comes a new climate, one far more extreme and unforgiving than anything in Earth's modern age. Supercontinents change everything. When land masses fuse, the interior regions drift far from the moderating influence of the sea. Without nearby oceans to balance heat and moisture, the heart of the continent becomes a furnace, hot, arid, and lifeless. Daytime temperatures soar above 50 degrees Celsius. The air dries. Vast deserts sprawl across the center of the landmass. Dust storms sweeping over plains that once held forests. Meanwhile, the coasts endure brutal monsoons, violent, seasonal floods where ocean winds meet the heat of the interior. The great ocean surrounding this new Pangaea will trap heat and alter global currents. The familiar Gulf Stream and Antarctic circumpolar current will vanish, replaced by entirely new circulation systems. The poles may thaw completely. Tropical zones may stretch across half the planet. and Earth could enter an era of super greenhouse conditions, a climate of fire, dust, and endless storms. As the continents move, so too will the heavens change. The stars we know today, the constellations that guided our ancestors, will fade and distort. The Milky Way itself will evolve, its arms shifting shape as our solar system drifts around the galactic center. In 250 million years, the familiar night sky will be gone. Sirius, Vega, Betelgeuse, all will have burned out, moved on, or been replaced by newborn stars. The Moon, too, will retreat, drifting several meters farther away with each passing century. It will appear smaller in the sky, its gravitational pull weaker, its influence on tides diminished. The Earth's day will lengthen as its rotation slows, its tilt perhaps shifting as mass redistributes beneath the crust. Even time itself, measured by sunrise and sunset, will be subtly rewritten. To an observer standing on the surface of this distant future Earth, the world would be both familiar and utterly alien. A different sky, a different sea, a different home. Life has always adapted to Earth's changes, and it will again. When continents collide, ecosystems collapse, but evolution thrives on chaos. Species die out, but others emerge to fill the void. In the far future, as deserts spread and mountains rise, life will migrate and transform. New forests will take root along the coasts of the great supercontinent. New oceans will teem with creatures evolved to withstand warmer, salter waters. Perhaps mammals will have long vanished by then, replaced by descendants unrecognizable to us, forms suited for blistering heat and relentless storms. Perhaps life will have gone underground or underwater, thriving in places untouched by the scorching sun. Or perhaps, by then, humanity, or whatever we become, will have left Earth entirely. Looking back at our old home from another star, we might watch this transformation unfold from afar. We would see the continents fuse again, the seas retreat, and the face of our world change, the slow pulse of a living planet continuing long after us. The formation of Pangaea Ultima will not be the end, merely another chapter in an endless cycle. After millions of years more, even this supercontinent will break apart. Rifts will form, new oceans will open. The dance of tectonics will begin again, as it has for billions of years. The Earth has seen at least 3 supercontinents before: Rodinia, Pannotia, Pangaea, and it will see more. The cycle of collision and separation is eternal, driven by the slow heartbeat of the planet's molten core. Even the continents we know are not permanent. They are waves in a geological ocean, rising, breaking, and reforming endlessly. And in 250 million years, our world will simply be another shape in that ongoing rhythm, a fleeting configuration in the story of a planet that never stops changing. Imagine standing on the shores of Pangaea Ultima. The sun burns red and swollen, its warmth harsher than ever before. The air is thick with heat. The horizon stretches unbroken, one continent beneath one sky. No trace remains of the cities we built, the borders we drew, or the names we gave to land and sea. All of it has been folded into the slow, unrelenting current of time. The Earth endures. It always has. Long after humanity, long after the last traces of civilization fade, the planet continues its slow dance, continents drifting, oceans rising and falling, mountains collapsing into dust. It is a world both ancient and newborn, forever reshaping itself, forever alive. And somewhere, in that far distant age, the Earth still turns beneath the same sun, a testament to the power of time and the endless motion of a living world. Because even 250 million years from now, the planet will still be breathing, still changing, still beautiful,